Hello everyone. After 280 days, the activity of a radioactive sample is 6,000 dps. The activity reduces to 3,000 dps after another 140 days. Initial activity of the sample is in dps. So we know that the activity reduces with the half-life is like this, where n is the number of half-life. So here it is said that after 240 days and half-life is this. So number of half-life will be equals to 2. Right. So I'll say here after 2 half-life. So here I will write 6,000 is the activity and the number of half-life is 280. So I will write 2 to the power 2. It will be 24,000 dps. Now you can see the correct option here will be D, 24,000 dps. Thank you.
Well, hello students. Now we're going to see this question. The question says that the half-life 215 of AT, okay, AT is an element, okay, is 100 microsecond, okay, so mu s, okay. So find the time taken for the radioactivity of sample of 2 to the of 215 AT, okay, to decay 1/6 of 1 by 16th of its initial value, okay. That means what is being told in the question that the initial value, let's suppose the initially it was taken as A naught, okay, and the final value is 1 by 16 times of A naught, okay, and basically the T half is given as the 100 microseconds. So basically, firstly, I'll explain you T half so that we can do this question very easily. T half is the time taken for the sample for the sample, you can say radioactive sample, okay, radioactive sample to decay to half its initial value, okay, half its initial value. Got it? So basically over here that means what, when A naught goes to A naught by 2, this is basically what, 1 T half, okay, means one time T half has been done. So now what we'll do, we will solve it like this only and not using a formula. So when this is taken as initial concentration, now this will also go half, so half of A by 2 is A naught by 4, so again 1 T half will be there. Okay, again this A naught by 4 will become half again, so this will become A naught by 8, so this will become again one more T half, okay. And lastly, one more time when this A naught by 8 will go its half-life, undergo its half-life, so it will become A naught by 16 and it will again do a T half. So basically, if you see, there are 1, 2, 3 and 4 times T half. Okay, means 4 times half-life is taking place. That means what? Total time will be equal to 4 times of T half. Okay, that means what? 4 times of 100 microsecond. That means what? This will be equal to 400 microsecond. Got it? So we didn't use the formula and we found out the answer. If you do it this way, this will be very efficient. Understood? So our answer will be clearly option number A, that is 400 microseconds. Got it? Thank you.
देखिए इस क्वेश्चन में बोला है कि एक रेडियो एक्टिव सैंपल है जो कंसिस्ट कर रहा है दो डिस्टिंक्ट स्पीशीज को जिनके इक्वल नंबर ऑफ एटम्स हैं इनिशियली. मीन लाइफ ऑफ एक स्पीशी है टाउ और दूसरे की है 5 टाउ. डिके प्रोडक्ट्स दोनों ही केसेस में स्टेबल हैं. अगर हम प्लॉट ड्रॉ करें टोटल नंबर ऑफ रेडियो एक्टिव न्यूक्लियाई में एज अ फंक्शन ऑफ टाइम, तो कौन सा फिगर रिप्रेजेंट करेगा इस प्लॉट को. तो देखो जो हमारा सैंपल है उसमें जो दोनों स्पीशीज हैं वो क्या कर रही हैं, वो रेडियो एक्टिव सैंपल है तो वो डिके करेंगी टाइम के साथ साथ. ठीक है, डिके करेंगी, बोथ स्पीशीज विल डिके with time to form स्टेबल न्यूक्लियाई। ठीक है, तो अगर फर्स्ट केस में देखिए, क्या हमारा किसी भी टाइम में कोई चेंज नहीं आ सकता? क्या नंबर ऑफ न्यूक्लियाई कांस्टेंट रह सकते हैं? नहीं। क्यों? क्योंकि वो साइमल्टेनियसली डिक्रीज करते जा रहे हैं दोनों ही, तो कांस्टेंट का तो केस पॉसिबल है ही नहीं। नंबर ऑफ न्यूक्लियाई कैन नॉट रिमेन कांस्टेंट, तो हमारा ये फर्स्ट ऑप्शन गलत हो गया। सेकंड में देखिए, पहले तो डिक्रीज कर रहे हैं मीन लाइफ तक, लेकिन मीन लाइफ के बाद क्या हो रहे हैं? इंक्रीज करने लग रहे हैं, ये भी पॉसिबल नहीं है। नंबर ऑफ न्यूक्लियाई कैन नॉट इंक्रीज, हम हमेशा डिक्रीज ही करेंगे, इंक्रीज नहीं कर सकते। ठीक है, तो बी ऑप्शन भी गलत है। डिके करना मतलब डिक्रीज करना, इंक्रीज डिक्रीज इंक्रीज डिक्रीज का कॉम्बिनेशन भी सिमिलरली नहीं हो सकता। डी ऑप्शन में बोला है कि हमारा क्या कर रहे हैं? नंबर ऑफ न्यूक्लियाई डिक्रीज कर रहे हैं एक्सपोनेंशियली विथ टाइम। नंबर ऑफ न्यूक्लियाई डिक्रीजेस एक्सपोनेंशियली विथ टाइम, ये ट्रुथ है, ऐसा ही होता है, हमारा रेट लॉ भी यही बताता है। तो ये हमारा डी ऑप्शन करेक्ट है। ठीक है, इस क्वेश्चन में।
Hi everyone, so we are given with a question which says there are two radioactive material X1 and X2 having decay constant as 10 lambda and lambda respectively. If initially they have same number of nuclei, then the number of nuclei of X1 to that of X2 will be 1 by E after a time. So we need to calculate the value of time after which the ratio of X1 by X2 is 1 by E. Alright, so by decay law we can say, or by disintegration law we can say, n is equals to n naught e raised to minus lambda t. So this is what the expression is. So this expression we have to clear with the terms. So we can say n naught is the number of nuclei present initially, n is the number of nuclei left after time t. Alright, so let's say this is our equation number 1 and we will now try to implement it in the given question. So we can say for first it says for x1 we can write, for x1 we are supposing initial number of atom to be as n naught 1, so, and after time let's suppose t we are assuming it as to be n1, so we can write n1 will be equals to n naught 1 e raised to minus lambda 1 t. We are interested in finding this value of t only. So from here if you substitute its value, n1 will be equals to n naught 1 e raised to minus of lambda has been given as 10 lambda into t. Let's say this is our equation number 2, and finally for 2 we can write the similar expression, that is we are assuming a number left as n2, initially it is n2 n naught 2 e raised to minus of lambda t, because lambda, that is decay constant, is been given as lambda for x2, so we are just directly substituting this value over here. So we can say so let's say this is our equation number 3, so we can take the ratios of it and we can say from 2 and 3 we can write, from equation 2 and 3 we can say n1 by n2, and since the initial number, that is n naught 1 n naught 2, is been given same initially number of nuclei, so they can be cancelled out. So what we are left with is e raised to minus 10 lambda t divided by e raised to minus lambda t. Alright, and finally we can say this can be written as e raised to minus lambda t raised to 10 dividing by e raised to minus lambda t. So what we are left with is, therefore n1 by n2 will be equals to e raised to minus 9 lambda t. Alright, so from here we can say, and this ratio has been given as 1 by e. Alright, that is we can see clearly from the given question, so we can substitute its value over here 1 by e, and that will be equals to 1 over e raised to 9 lambda t. If we cross multiply the things, so we can take e raised to 9 lambda t will be equals to e. So now if we take log on both sides, so what we are left with is 9 lambda t log e, and that is equals to log e over here. So log e value is 1, so therefore we can say the value of t comes out to be 1 over 9 lambda. So this is what the time we are getting, and we can give the reason over here. Log e value is 1. Alright, so this is what the answer we are getting to this question. So if we compare it with the options, so we can say option D is the right answer to this question. So I hope you have understood the concept, and thank you for watching.
In this problem, we have given the half-life period of a radioactive element X is same as the mean lifetime of another radioactive element Y. Okay. Initially, both of them have same number of atoms. Then, which option is correct? So, according to question, we have given the half-life is equals to mean life. Okay, so half-life can be given as ln2 upon lambda of x is equals to mean life can be given as 1 upon lambda of y. Okay, so ln2 is what? ln2 is 0.693. 0.693. The value of ln2 is 0.693 upon lambda of x will be equals to 1 upon lambda of y. Okay, so from here we can write lambda of x will be equals to 0.693 times lambda of y. Okay, 0.693 times lambda of y, or we can say lambda of x equals to 0.693 lambda y. Thus we can say that lambda of x is less than lambda of y. That means rate of radioactive decay of x is substance x is slower than rate of radioactive decay of substance y. That means y is decaying faster than x, so y will decay. Therefore we can say that y will decay at a faster rate than x. Okay, so let's check the option. So we can say that option C is the correct answer of this problem. Thank you.